Hello, and welcome to the second episode of From Oracle Cloud to Multi-Cloud Mastery. My name is Arun Yadav, and I am an Oracle ace. In this session, we are going to take a deep dive into cross-cloud networking. So what all we will cover in this one? We will discuss why cross-cloud connectivity matters. What are the various networking options? What are the communication patterns, and what all should you keep in mind while building these connections? All right. If you are here and if you have watched the first episode, you already know what multi-cloud is and why it matters. And the reasons to have cross-cloud connectivity are basically the same, whether it is low latency, a DR strategy, or aligning with governance and compliance policies. If you have chosen the multi-cloud path, they are required to be connected to take full advantage of various cloud offerings rather than have your resources operate on individual clouds in their own silos. Now, let us look at the various options that are available for cross-cloud networking. There are three main ways to connect Oracle Cloud to other environments. One is site-to-site VPN via IPsec, which is nothing but an encrypted tunnel over the internet. It is easy to set up and often pocket-friendly. This is ideal for securely connecting multiple locations that are geographically dispersed as if they were in a single network. The second option is dedicated interconnect. For example, OCI's Fast Connect with Azure Express Route. This gives you a direct private connection offering higher bandwidth, reliability, low latency, and better security. This is perfect for production traffic or workloads and sensitive workloads, or to connect your cloud infrastructure with your own on-premise data center. The third option is the private links or endpoints, which also provides a direct private access to services, for example, Oracle Autonomous Database via a private endpoint. This option also avoids the public internet entirely and many times used for secure SaaS to SaaS integrations. Now, let us take a look at the various networking constructs and compare them. So the cloud network, which is nothing but a software-defined network, a cloud provider's network is called um, the virtual cloud network in OCI. In Azure and GCP, it is called the VPC, that is the virtual private cloud, and in Azure, the VNet. That is nothing but virtual network. In OCI, AWS, and Azure, the cloud network is at a regional level, which means if you have subscribed to two cloud regions in OCI, for example, Ashburn and Phoenix, you need two VCNs, one per region. Whereas Google's single VPC, a single VPC can span multiple regions. The global VPC by Google Cloud offers a single IP space across regions, making it easier to deploy applications across different regions. Whereas a regional VCN provides stronger resource isolation within a region. Now let's talk about subnets. There are two kinds of subnets. A public subnet that allows resources to communicate with the resources in the open internet and vice versa. The private subnet that allows communication between resources within the same subnet and the open network. However, the resources from the internet or the open internet cannot communicate with the resources within the private subnet. Each VCN must contain a subnet, either public or private, does not matter, but it has to have one. In OCI, a subnet can be region or availability domain specific. In AWS and Azure, it is availability zone specific, whereas in GCP, it is a regional subnet. Access to internet for the resources can be allowed using an internet gateway. I'll talk more on the different type of gateways in the upcoming slides. Now let's talk about the VCN security. VCN security is managed by security lists. That is nothing but a set of firewall rules or NSGs, that is network security groups, or a combination of both subnet security list and a network security group. In OCI, you can have up to 5 security lists per subnet and up to 5 NSGs per VNIC. Network security lists or network security groups are recommended over security lists as NSGs provide a much granular level of control over what kind of traffic is allowed for what kind of resource. Network peering is one that enables different VPCs or VCNs, that is virtual private cloud or virtual cloud networks, to connect and communicate with each other. You can have local and remote peering based on VCNs that are within the same region or different ones. Now, let us take a look at peering and various gateways in the next slide. These are the different gateways that you have. An internet gateway, which is nothing but a virtual router that allows to and fro communication between resources that are residing in a public subnet and to the open internet. That means those resources can also be accessed from within the open internet. Anyone out there in the open internet should be able to connect to those resources if you do not have proper security in place. The second one is the NAT gateway, which is the um, network address translation gateway. This allows resources in private subnet to communicate with the open internet. But the resources in the private subnet remains invisible from the reach of the open internet. In OCI, unlike other cloud providers like GCP, AWS, or Azure, the NAT gateway is not dependent on an internet gateway. The third type of gateway is the service gateway. This allows the resources in your private subnet to communicate to any public-facing Oracle resources while remaining within the OCI network. For example, it does not make any sense if you want to access an object storage bucket and if you want to patch your Linux VMs and you need to access the publicly available resources to do so, and you have to go to the public internet. The network goes from your private subnet to the open internet, access and those resources which are there in Oracle network come back to the come back to the open internet and then again reach to the OCI network. The service gateway avoids the open internet completely. It is also similar to private link in AWS and Azure, and the private service access in Google Cloud. The fourth one is local or remote peering gateway. The local peering gateway is used to establish communication between different VCNs within the same region. The remote peering gateway, however, is to establish communication between VCNs in different regions. For example, if you have subscribed to 2 regions within OCI, for example, Ashburn and Phoenix, you will have at least one VCN in each of these regions. And if you want to have a connection between these 2 VCNs, then you will have to use a remote peering gateway. The last one is the dynamic routing gateway. This is the most powerful one. Basically, you can leverage DRGs or dynamic routing gateways for remote peering connections. That's when you have 2 VCNs, each one of them in a separate region or different cloud providers, or even for connecting your on-premise data centers with your OCI tenancy. And you can also attach more than one VCN to one DRG. Actually, you can attach up to 300. It uses the BGP, that is the Border Gateway Protocol, to automatically advertise your CIDRs, route prioritization, and failover. All right, now let's take a look at the connectivity between OCI and Azure. The OCI Azure interconnect is a direct physical link between Oracle and Microsoft shared regions. It offers private IP reachability. And so your OCI network can talk directly to your Azure network using private IPs without needing a VPN tunnel over the internet. It also offers up to 10 Gbps of speed with low latency. And you can use it with a combination of, for example, Fast Connect and Express Route for things like connecting to Oracle Fusion SaaS and Azure Identity or Azure Active Directory for identity, or maybe integrated applications in Azure and OCI. This, however, is not the case or used for the latest multi-cloud offerings from Oracle, with that is Oracle Cloud at Azure or at Oracle Database at AWS or Oracle Database at GCP, because in that offering, it the Oracle Database at Star Cloud shares the same physical OCI and Azure or that Star Cloud data center location. There is the reference link for you to explore more. What about now OCI to AWS or OCI to GCP connectivity? For connecting AWS, you can use a combination of dynamic routing gateway on OCI side and AWS transit gateway for scalable routing. For connecting the Google Cloud, you can use a combination of dynamic routing gateway on the OCI side and the GCP Cloud router or a partner interconnect with BGP routing. GCP's shared VPCs help centralize routing, and OCI DRG will help manage the outbound and inbound traffic. This is the reference link for you to seek more into how to access the Google Cloud Platform from within OCI. All right, that is all as far as Module 2 and Episode 2 is concerned, where we covered the various options and options available for the multi-cloud networking. In our next module, we will cover identity and access management. Until then, stay curious, stay cloud smart, and thank you for watching From Oracle Cloud to Multi-Cloud Mastery. Ciao. And I had to use ciao because my daughter wanted it. Have a good one.